Let's take a look at another example, but this time f of xy is going to be x plus y, 3x minus 2y, and then just x. Now, if I want to find f of u, where my u is just 1, 0, then I need to find f of 1, 0, and I can just plug in 1 for x and 0 for y here. So this is going to be 1 plus 0, 3 times 1 minus 2 times 0, and then just 1. And this is going to give me 1, 3, and then 1. On the other hand, if I want to find f of v, which is f of 2, 3, I can just plug 2 in for x and 3 in for y. So this is going to be 2 plus 3. The next one is going to be 3 times 2 minus 2 times 3. And the last one is going to be just 2. So I'm going to have 5, 0, and then 2 here. Now, if I want to find f of u plus 2v, then I'm going to need to first find u plus 2v. And u plus 2v is going to be just the vector 5, 6. So f of 5, 6, I can once again plug 5 in for x and then 6 in for y. This is going to be 11. I'm gonna have 15 minus 12, which is 3. And then I'm gonna have just number 5. Now, if I want to find fu plus 2fv, then I can just use fu and fv that we have computed from part A and B from earlier. So this is going to be 131 plus 2 times 502. And this is going to give me 11, and then 3, and then 5. But notice that this time my pink vector and my green vector is the same. And this is indeed because the function that I have here, this is a linear transformation, so it preserves linear combination. When I have a function f of a linear combination, it's the same as the linear combination of the function f that I have. So let's try the next one. If I want to compute f of 3u minus v, then I can first compute 3u minus v. And my vector u is 1, 0, and my vector v is 2, 3. So then 3u minus v is going to be just 1 and then negative 3. I can kind of do that here. 3 times 1, 0, minus 2, 3. This is going to be just 1 and negative 3. So f of 1 and negative 3, I can just plug 1 in for x and negative 3 for y. So I'm going to have negative 2. The next one is going to be 3 minus 6. So that's going to be 3 plus 6. I'm going to get a 9. And the last one is going to be just 1. On the other hand, if I want to compute 3 times f of u minus f of v, once again, I can just use the value of fu and fv from earlier. This is going to be 3 times 131 minus 502. And this is going to give me, let's see, I'm going to get 3 minus 5, which is going to be negative 2. I'm going to get 9 minus 0, which is a 9. And then I'm going to get 3 minus 2, which is a 1. So once again, my pink vector and my green vector, this is the same. And this is indeed the property of a linear transformation. F of linear combination is the same as the linear combination of f.